get started then. My name's Megan. I have Shreya with me here, who I will hand it off to in a few minutes to give you the demos and show you how things work. But let's just walk through Qualcomm AI Hub, to use it, what it is, and give you some more information on it first. So here we go. Okay. We hope you enjoyed this morning's talk. If you attended it with Siddika, who walked you through why we built Qualcomm AI Hub and when it should be used. If you missed it, we'll do a quick recap now before we shift over to the demo, and then we want you to try it yourselves. And if you had any questions, we're here to answer them. So let's move to what is Qualcomm AI Hub and what are we doing here? We all know that there are AI experiences all around us, whether that's as simple as text completing when you're writing in an app and you see your autocomplete sentences, or maybe it's even your Roomba going around your house vacuuming, and it has AI powering it to know where to go and where there's still dirt on the floors. And so it's become commonplace to talk about AI. I'm sure you all get questions about what Gen AI model you're working on, or maybe you even get sent a model and are asked about it. And so what we're trying to do with AI Hub is make it easier to bring these experiences onto the device. And we want to make every product more intelligent. So that's our goal with AI Hub. So before we shift completely to the product, we want to talk a bit about why on-device AI. Because obviously you could deploy your models in the cloud as well, but our focus is on-device. And that's for a couple big reasons. The first being cost, because then you don't have to worry about any cloud costs that you're incurring running the models if everything is running on the device that's in your pocket or in your user's pocket. The next is privacy. So, when you're keeping the model on device, you don't have to worry about these intelligent experiences bringing the user's data to the clouds or being transmitted to many different servers because it's all staying on their device. And then lastly, the biggest thing is performance. So in order for a model to run as fast as possible, you don't want it being sent from your device to the cloud and then back just to, start detecting the object that you're looking for in your app. So we want to run as fast as possible, and we want these experiences to shine. So because of that, you want to keep everything on device. And of course, with that, there are challenges, and that's what motivated us to build AI Hub. So we've been in this space for a long time now, and we've seen, all of these issues and more, whether it's the model not being fast enough, the app crashing, it taking too much memory. It could be anything. Obviously, this isn't, a holistic list of all the issues you could face, but we've hit a lot of them, and that's why we have AI Hub to help you through this process and to make deploying on device easier. So if we move to what use cases we're solving with AI Hub, you see a couple of them here. The biggest thing is getting started, because even if you're like an advanced app developer, maybe you haven't really dealt with bundling a machine learning model into your app before. And we want to make that easy with our platform. The next is performance across devices. So you'll see when we do the demo how many real devices we have for you to run your model on. And we want to make sure that you're using one asset and you're getting good performance on all of these devices. Because you can't control if your user has like the latest and greatest Samsung or Pixel, or if they have an older one that maybe doesn't have the same processors, but you want them to get the same experience and you want your experience to work, first of all. And then the last use case that we work on with AI Hub is rapid iteration. So maybe your model runs out of the box and you're using one of our open source models, and you can see the performance, but it's not as fast as you want it to be. We can help you iterate there and identify why it's not running quickly. And maybe it's not running on the processor you want it to run on, and we can give you pointers there, and you can iterate, run multiple jobs until you're happy with it, and then you can deploy it on device. So we'll just take a quick look at the pre-optimized models that I've been referring to. We have over 100, and if you don't see one that you like there, you can always bring your own and bring that to our platform to compile it and then download it onto your target device. So I'll do a quick demo of what these pre-optimized models look like and how to navigate the site, and then I'll hand it over to Shreya to show you our product and the APIs there. So let's just go to aihub.qualcomm.com, which hopefully you've visited by now. You can go ahead and enter, depending on which device you're looking to deploy to, you can enter one of these, we call them worlds. But you can also just go ahead and press all models if that's, you don't know what device you're looking for yet, or maybe you just want to deploy to many devices, the same model. So of course we're gonna have to wait for the Wi-Fi to catch up with what I'm saying here. But once it loads, we'll get over the 100 models that I've been alluding to, and we can show the use cases. Maybe we should have had a tab open already. All right, I'll just talk through this piece so we don't have to wait for the Wi-Fi to load here. But essentially, when you get to any of the pages, whether it's mobile, compute, automotive, IoT, or all models, you'll see the models that are applicable for that device. And you can then filter by the model that you're looking for. So maybe you want to deploy an object detection model, or it could be image segmentation. We have lots of different models for different use cases, and you can click into them, and then you can see, depending on the device you're looking to deploy to, which models are applicable. So we're not going to set you up with a model that we know doesn't work on that device. You can take that model, you can take a look at the performance of it, the latency, the memory, where it's running, all the things that we would do. And we are, our own biggest users of AI Hub. And we'll go and run these models and make sure that everything looks good. And then at that point, you press the download button and go and use that model. So we'll come back to this. Hopefully it'll load by the time we're done talking about the rest. But I'll hand it over to Shreya to talk more about how our APIs work and show you a quick demo.
This was the presenter. So I think any developer's workflow is pretty simple, and it can be thought and broken down into steps. So the first step is always to pick a model. So you can either pick a model from all of the models that we already have on our website, or you can bring your own from Hugging Face or any other open source project on GitHub. And then you have to decide your target platforms. For example, we have mobile, compute, IoT devices. And for example, if you picked mobile, after that, you have to decide what runtime to use. So for a mobile device, you can actually deploy on TF Lite, Onyx, or QNN directly. So if, for example, you picked TF Lite, then you already have your model, you have your device, and you have your runtime. Then you just need to test and validate on that device. And once you're happy, you can just use this particular model and deploy it on the device. So let's go a little bit further to understand how the AI Hub developer workflow is. So once we allow you to pick models from our website, which are also on Hugging Face and on GitHub. Then you can bring your own model in the PyTorch format, the Onyx format, or quantized using AMET. And then you need to pick a device. So for example, if you picked Samsung S24 or a Snapdragon X Elite laptop, then you need to pick a runtime. And for Android, let's say we picked TF Lite, then you need to use AI Hub. So you can just use this model with this device and runtime and submit a compile job, which basically means that it compiles, quantizes, and optimizes the model, and it gives you the asset that you need to actually deploy on device. You can also submit a profile job right after you compiled, which actually procures a physical device and prepares it, and then you can actually run the model on device end to end, which helps you give the profile numbers that you want and validates it on that device. And then once you're validated, you know that the asset works on a real device. You can just download that. And all you have to do is get the runtime binaries like QNN or TF Lite delegate, and then put it on the app that we have. So we have a couple of sample apps as well. So you can just get them from GitHub. You can get the runtime and you can get the asset. and then you can just run the model on the device, and you're good to go. So here, it's just talking about the same workflow that I spoke about, where you take these source models and you compile and optimize for the hardware. So it basically changes the graph based on the hardware that you've picked so that it runs more efficiently, and it uses the more efficient chips. So the NPU being the most efficient. But you can also pick NPU, GPU, CPU, whichever one you'd like. So for example, if you have an app where you would not like to touch the GPU because it's a gaming app, then you could even specify compute unit NPU, CPU. So we would optimize it in a way that both of those compute units are being used. And you will be able to see similar profiling results, which is basically, this was the estimated end-to-end time, this was the memory footprint, and these were the compute units used. In an inference job, you get the results of your input data being passed through the model, and the output you can use to evaluate however you'd like. You can also analyze the model by looking at the graph itself. You can see which parts of the model were run on GPU or CPU. You can take them out, you can modify them. You could also see which layers and how much time they take. So you know how to design a network more efficiently if you have to. And moving on. So these are the APIs. I'm going to show a demo as well. So let's just go through them quickly, and then we can look at the demo itself. So here, we've designed our web service in a way that you interact with it via the Python client. And the APIs are pretty simple, pretty consistent throughout. So first, you want to run a compile job with your PyTorch model, which was traced. You just pick the device there, and you pick the runtime. So here, QNN is picked instead of TF Lite, but you could just change that to TF Lite, or you could altogether not pass this option. And then you just give the input specs, because a PyTorch model actually doesn't have an input shape. It's an unfrozen graph. And then once you have this, you've converted it to basically either QNN, TF Lite, or an Onyx asset. And you can use this asset on your target device to get the performance numbers. So, and that's something that we can even look at in the demo. And once you have, you're happy with the performance, right? You want to just cross-check if an actual data point looks and works as the way you want. You can run an inference job. So what it does is it takes an actual input, and it'll give you the actual output after it. You can compare it against your Torch input model, or you could actually visualize the output. And this is just a spot check, or ultimately make accuracy, like look at the accuracy of the entire model on a validation data set. So let's take, actually, before we take a look at the demo, maybe you guys can scan the Collab Notebook's QR code. So this is the notebook I'm just going to be using to actually demo the whole workflow. And you can follow along because you have AI Hub accounts already. Okay. 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 So here, so I'm not going to run it because our Wi-Fi is not working very well. But you can start running it, and you'll be first installing both the Python packages that we'd be using in the demo. So one is AI Hub, which interacts with our web server, and AI Hub models, which is the one which has 100+ models itself. So we're going to use an AI Hub model and try to run it through AI Hub and see how all of this fits. So for this, we've taken up FFNet, which is a semantic segmentation model. So first we can just import the model itself, and with the model dot pre from pre-trained is the way to get a torch traced model, and then we again trace it for the sake of the demo, because it's just the format that AI Hub accepts in a compile job, and all you have to do is pass one sample of input data to it for this. And once you've signed up on AI Hub, what you want to do is go to AI Hub altogether and go to the settings page. And that settings page essentially has your API token. So you can just copy that API token and then run QAI Hub configure API token and the token itself. What that does is now your Python client is linked to your UI itself after login. So now you will be able to run jobs using the Python client, and you will be able to see them in your UI account. And then when you do QAI Hub list devices, you can actually see that we have more than 100 devices available for you to pick and choose from and deploy to. So we have mobile devices going back to Pixel 3 to Samsung S24. We also have the X Elite, and we can pick the device here in this way, hub.device, and we just give the name of the device. Then for compiling, all you have to do is do submit compile job, take your source model, which was the traced torch model of FFnet, and run it with this device and give it an input spec, and just use the target runtime TF-Lite. So with that, we'd be able to, it's a little sad we can't see this, but we should be able to, yeah, I mean, can you just move back to the demo?
Yeah.
Sorry. Yeah. So anyway, so that website the website has a nice UI where you can see the model name, you can see the device name, you also will be able to see the input specs as well, and you can see the target model as a download button on the top right. And that when you click that, you should be able to download the model if it's successful. And using this target model, you can run a profile job. A profile job essentially is the similar UI, and it gives you the overall end-to-end inference time. It gives you the memory footprint. It gives you how many layers were run on which compute unit. And it also gives you a breakdown of all of the layers and on which compute unit they were run and how much time it took. You also see runtime configurations, which are basically the settings we use to run this model on device. And then you can just copy paste this into your app, and you should be able to get the exact same performance that we got. And you can also visualize the model, and you can see, where did the layer that ran on CPU was in the graph. So you can cut it out, you could make it a little different. Basically, you can debug it it's an intuitive way for you to debug your ML models if they don't fit under what you want them to be. Like if you want them to fit under a certain time limit, you can do a little bit more iterations and debug that. So after we run the profile job, right, and we already have the performance, even before that, the way, like, even if we want to deploy it on device, we would probably do like an accuracy check or a spot check of sorts. So we can run an inference job which takes actual input, and it can give you the actual output of running that model on device. And you can use that to calculate metrics like PSNR. So for example, you can compare the output of the torch model that you used in the beginning and the on-device model. And for example, we get a 78. which means that the pictures that you get out of Torch as well as on device is pretty similar and it's doing a good job. You can do it on a bunch of images to see how the performance is across the board. And then we also make it really easy to use AI Hub models. So we have a demo script that does all of this for you on your own, on its own. So you could just run the demo and you can say -- on device. And what it does is that it's going to take that FFnet Torch model and it's going to compile it to a TF Lite model and then use an actual data point like this one. And it is going to do an inference job on that. And then it's also going to get the output and post-process it and put it on the image itself. So you can see that the image is already segmented in the correct way. People are a different color, the backgrounds are different color, and the car is also segmented. So this is essentially the workflow that you can do to figure out if your model is good enough or not, right? It performs very well or not, if it's accurate enough for your application or not. And once you have that, you can just download this asset from the compile job that we ran in the beginning. And this is your asset for the app. And from our website, you can also go to AI Hub apps. And these apps are, we have like 3 sample apps. One is for image classification, one is for super resolution, and the third one is for semantic segmentation. So you can just pick the repo and you can clone it. And like I have it in my Android Studio, you can just basically open the app and it has clear instructions about where you can put the asset that you just downloaded. So for example, we have the FFnet 4s.tf Lite here. So you just have to put it in this location, then connect your phone. So for example, I've been running everything on my S24. So I'm just going to connect my S24 to the app itself, and I can just compile the app. And then I will be able to get an app that has the asset and all of the required run times and everything on it. So let me quickly. So I already compiled the app. So I already have it on my S24 with do you know how to close the app and open the app?
Which app?
This app?
Yeah.
Oh, it's.
Oh, how you okay.
Oh, yeah. Okay. So if you look at this app, it's the same model that we basically compiled with, and it can. See it here.
So I'll just narrate what Shreya's doing so you can see. But essentially, she's just holding her S24 to do the street segmentation because this is a street segmentation app. We can't get it to segment, all of you. But you can see the app running on the device there. So it's as simple as just grabbing that asset and either taking our sample app or building it on your own. And then you have the app on device.
Yeah. And you guys can give it a try. Whenever you get time, like basically just get the GitHub repository, just put the asset from the compile stuff, and it should run out of the box for you all in under 5 minutes. And yeah.
So it might be kind of hard to try things out given we weren't able to load anything on the Wi-Fi. But if you're having better luck than we are, we definitely encourage you to try it out. And a couple other things that I'll mention. So if we head back here,
Oh yeah.
you can just take a look at our website. So when it is working, you'll be able to go to two key places. One is you go to the community tab and you'll see our Slack channel. We also have a QR code for that I'll put up in a second. So that's where you'll find our entire team. If you are using AI Hub and you're hitting issues, maybe you're just having trouble locating even where the API token is, we can point you in the right direction. If your model's not, compiling, then we can give you some pointers there, and we are actively monitoring that channel. And then there's two other pieces here. So there's the resources page, which you'll see if you click that tab up at the top. And that just showcases some how-to videos, our documentation, as well as some success stories. So you'll see different customers and how they've used AI Hub to deploy things into production. There's also a deep learning course that Krishna from our team has written up so that you can follow along and figure out, how everything works, and that could be a great place to start. And the last thing I'll mention here is our Get Started page. So that's what you're seeing on the right, which if you click Get Started, this is what it'll lead you to. And if you just copy and paste those prompts, that will bring you to the same MobileNet example that we've been showing in the slides. And that's a great way just to validate that your environment's set up correctly, but also that you're confident using AI Hub so that you can then swap in either your model or one of the other models, whether it's FFnet that Shreya showed or one of the other ones from AI Hub. So we encourage you to check that out. I'll navigate back just quickly to the Slack channel here in case you want to go ahead and join it, or you can always go to our website and join it later.